This is OXDF, and today I'm working on FlareLinuxVM from the Flare on 2021 challenge. It's the 5th challenge. They gave me a VM that I've gone in and I found a piece of ransomware that was encrypting all the files in the home directory documents, and it is encrypting them all and giving them a .broken extension. So I've pulled back the binary and we're going to take a look at it in Ghidra here. Opening it up, go ahead and analyze it. It's a super quick analyze because there's not a lot to this file. Under functions here, I'll come there and find it's not stripped, so I got all the function names, and I'll start with main. Now, a lot of times I like to really go through and understand line by line what's going on, but in this one I'm actually going to take a real quick, just sort of get the feel for what's going on approach. So rather than, typically I'll come in and what I really like to do is figure out what each variable is and rename it and retype it. I'm not going to do that here. I'm going to just try to get a feel for what's going on. It's made a little bit more complicated by all of these C++ object-oriented function calls. But again, at the end of this, I'm just looking for the feel here. So, for example, right at the top here, I've got getemp home. I already mentioned it's encrypting in the home directory, so that makes sense to see that there. We can rename this home dir string, for example. And then we can see that that's put here and passed into a different different variable here, and this is just a C++ variable string, so we'll call it home dir C string. Let's see, scrolling down a little bit here. Oh, here we have a basic string function. The operator is plus equals, and it's the home dir string plus documents. Cool. So now we're building up this string to now include the documents folder. That makes perfect sense. That is actually passed in here. So this is going to be the docs folder string, and then we open it. Awesome. So we'll just go ahead and rename that to docs folder open. And so as long as that's not equal to 0, we're going to go into this while loop, and the while loop is going to read a file name. So we're going to just call that file name. And as long as it's not 0, we're going into this loop here. And again, there's a bunch of stuff here, but let's just do a quick scan through. It's looking for this dot, and it's looking for dot dot. So probably I'm going to guess just off the top of my head, it's trying to ignore those files because Linux is going to return those in the list, and if those aren't the files they want to handle. But then if we end up back in this big chunk here, well, right there is quickly enough we can see, since it's not stripped, there's a function called encrypt. So that's definitely where we're going to want to take a look. Let's look back a little bit and figure out what's being passed in there. Interestingly enough, there's this operator new. It's creating a new array of characters that is 400 which is 1 megabyte or 1024. And if I look up a little bit more, let's see. So that local 30 is passed in. It's mentioned here. Do we have? So this is actually where we're reading from an IF stream, so a file stream. So I'm going to go ahead and I can presume this is probably reading in the file contents up to the first megabyte. If I want to test this, I can come over here. So let's see. The encrypt function is called, we'll scoot this over a little bit, is called right here at 401 BEB. So let's come over here. We'll create a dummy text file here in my home directory. I just put 10 A's in it. And we will run GDB. We'll do a break at that point, and we will run. And we hit our break. And we can see right now there's this call to encrypt, and what is being passed in is the address of the string that is my input. So right there, cool. We verified that's exactly what we thought it was going to be. So we'll just call this rename variable file contents. Sweet. Right there, that's probably enough. The goal here is I've got this directory on the thing in the VM that is a handful of encrypted files. I think I need to get them decrypted, so understanding the encryption mechanism is really where I want to be. I'm going to do the same thing here. Again, a lot of times I like to go through and name every variable and type every variable. I'm going to just try to do a quick scan. Right here at the top, I see this kind of key material, or this constant string being put here. So I'm going to actually retype this. I think there's probably a better way to do it than this, but for me, I always just make this a character array. Actually, before we do it, we should check and see. So it's 1, 2, 3, 4, 5, 6 and a half words. So 6 times 8, 48, 52. So we will make this retype variable char52. And now it still shows them in this kind of like one word at a time, but at least now it's all named local 68, and I can even rename this. And so we'll call this initial init vector. I'm not sure, that's probably not the right cryptographic term, but we're going to go with it for now. So you have this init vector. So now we have this other, let's see, so we have a loop here. Anytime I see a loop, of course, I like to do just call it I because it's simpler. So I, for I is less than 256, it's just setting this thing equal to I. So let's call this, this is going to be another init array. And again, I'm just giving these kind of like dummy names so I can keep track of them. And plus then I know if I've renamed them, it means I've already looked at it. Local var equals 10. So we'll center click on this and see it's kind of being used all through here. I'm just for now going to rename it var1. I've got another for loop here, so we'll call this I2. And let's see, we're going through here. I can spend a few more seconds and just quickly clean up, it's doing all these shift operations, and it's kind of what you expect when you're trying to generate a cryptographic stream. It makes perfect sense that it's doing all this shuffling up and mixing based off of this initial vector. What I really want to figure out is, how does the data that I'm passing in impact that? And what jumps out at me right away is, if I come up here, let's see, so param1, let's rename that to file contents. And the only place file contents is used is in this last line. And we'll go ahead and easily, just for readability here, set this to I3. Basically, it's looping over x400. So we passed in 400, again, 1 megabyte. It's looping over that 1 megabyte. And for each iteration of the loop, it's taking that byte and it's XORing it with some other stuff, and it's saving it over it. So what do I know here? Well, for one, it doesn't seem like the contents of my file matter at all up until this last line, which is really nice for me, because that means it's generating a constant key stream, and that key stream is going to be independent of the contents of the file. And so if I can somehow capture that key stream, I can decrypt any of the files encrypted with this program, which is really nice. Now, there is something right away that jumps out at me. Local 1C is set in both these places. This can't be right. Because if file contents, if some byte out of file contents is XORed by local 1C and local 1C, that's the same as file content. The same byte's going to come out. Because if you XOR something with itself, that is zero. That is a null byte, and if you XOR something with null, you get itself. So that can't be right. I'm going to go ahead and guess that Ghidra is trying to decompile here, and it's mixing up its variables. And I can verify that by coming over here. So I'm going to pay more attention now to this is the decompile. I'm going to come back to the disassembly, and there's these two XOR operations happen right here and right here. My theory is that the byte is going to be loaded into ESI. So let's see, that comes from EDX. Yeah, so here, RDX is probably in this case going to be the let's see. Yeah, so I3 is loaded into EAX, which is moved into RDX. Then this local 470, which I'm guessing is probably the input, the address is getting loaded into RAX, and then the I is getting added to it to push that far into the buffer. Then it gets from that address, it gets a single byte and loads it into EDX, which is then moved into ESI, and then ESI gets XORed twice, here and here. So what I want to do is figure out, okay, what are the things being XORed there? And again, I could go through and try to do it in here, but instead this is where I'm going to turn to GDB. So that XOR operation, let's grab this address right here, happens at 936. So we'll copy that, come over here and put in a break *OX, paste that in. And the second one, that one's there, and the other one was at 4D, right there. So I'll continue now, and I hit the second breakpoint, and I can see, so there's my input in RSI, right where I expected it, and it is XORing RSI with EAX. In this case, it's 0. Okay, let's continue to the second one. So still RSI is my input, and in this case, it's XORing it with ECX. So ECX is 61. So 61 and 0. So the first byte in the key stream that's being XORed against the plain text is OX61. And in fact, I can write that down if I want to start keeping track of this. Let's see. 0x61 is the first byte. Let's find my spot here. Cool, so let's just keep going through the loop. This should be the second byte. So here's my second byte is A. Maybe it would have been nice if I did A, B, C, D as content instead of all A's. In this case, so the first one, 61. And let's continue now to the second breakpoint. And this time, the XOR of the 61 in the input has already happened here at RSI, and now we're going to do it by 40. So let's come back here. This is going to be 0x61 by 0x40. And I don't know if we could pull up a binary calculator and do this. I will, in fact, I can show you. I can also do this in my head if you've done it a while, but if you just open up your calculator and do, let's see, we're in hex mode already, so 61 XOR 40 is 21. So 0x21. We'll go ahead and do one more here while we're, just for good measure. So continue, back at the first breakpoint, so standard, the input's here, 40 is the first XOR, and the next one's going to be whatever's in our CX, F, 40 and F. So we'll come here and we'll do OX40, XOR OXF, and that, again, I can show you with a calculator, but that is just going to be OX4F. And so I'm going to stop here for now because so what I could do, and actually what I started doing for just a minute when I was first trying to get this, was I could actually write a GDB script. You can put in commands at your breakpoints. And so I could do something where for when it gets to this breakpoint, print out, when it gets to this first breakpoint, print RAX and then continue. And when it gets to the second breakpoint, print RCX and continue. And then I have this long list of stuff I could copy and paste it, manipulate it a little into a file, maybe write it into a Python script. But what occurred to me is if I pass in an empty file or a file that is 1 megabyte of null bytes, that then when it XORed those null bytes with the keystream, I would just get the keystream out. And so that is actually what I wanted to do next. So I'll come over here and I will say, we'll do Python 2. It's the one time I want to use Python 2 because the print is easier. -C to do a command. So we'll do print OX00 times 1024. And we'll save that to documents, and we'll call it null.txt. And then we'll run this Zype command, and it cleans null.txt. And so now what we can do, xxd null.txt.broken, and do less. And right here, if you remember from our keystream that we started recording was 61, 21, 4F. And so you can see 61, 21, 4F. I've started capturing the keystream, but here, with 30 seconds worth of work, I've got the entire keystream up to 1 megabyte. So what I did next is I'll create a Python script that reads in this buffer of keystream, and then it can read in any file and decrypt it. I was comparing notes with a friend, diefunction, and he pointed out an even smarter way to do this, which is the script is going through and looking for any file in the downloads directory with a .broken extension. Well, because the XOR function, when you XOR something with a random byte, if you XOR it with the same byte, you decrypt it. Cool, okay, that's great. So if I take the encrypted files and I just give them .broken, if I remove the .broken from them and then run it again, it'll encrypt them a second time, which is just XORing them a second time, which is effectively decrypting them. And so I can just do that and get all the clean files out as well. So either way works, both pretty neat. So I'm going to stop the video here. I'll continue the rest of the problem in my blog post, but thought you might find this interesting. Thanks and talk to you next time.